So if slope is the rate of change, it's how fast something changes, then we have to figure out a way to calculate that, right? And so for example, take a look at this. If let's say the weather, right? If the weather was, you know, in the morning, if it was this cold, and then at noon it warmed up, so now it's at this temperature, right? How much did it change? In going, let's say, a matter of 4 hours, right? How much did the weather change? Well, it went from here to here, right? It went up that many units. So maybe it went up from like 60 degrees to 90 degrees, right? And now suppose another day from 8 to 12. At 8 o'clock, it was here again. And then at 12, it's like that warm. All right? So within the same amount of time, how much did it change? The same amount or less? It changed less, right? So yeah, both of them are changing, but how quickly is the weather changing? That is slope. Okay? And so how do we find it? We look at over a given time, how much did the vertical change, right? If we go over an x a little bit, how much does the vertical change? Now, another way to say if we go over an x a little bit is change in x. And then the symbol would be, what's that symbol, that triangle? Delta x. Delta x means the change in x. So it's how much it changed over the y over how much it changed in the x. All right. So that's the definition of slope. And now, if I wanted to figure out how much in the y-axis this weather changed from 60 to 90, what would I do? Well, how big is that change? How many degrees? 30 degrees. How did you do that? You did 90 minus 60, right? And if I wanted to figure out here how much time has changed, what would I do? 12 minus 8, right? So the way we figure out the change is by subtracting, all right? So change is calculated by subtracting. All right, and so this formula you've seen like a million times in your life, right? M is y2 minus y1 over x2 minus x1. So it's important that it's the change in the y over the change in the x, all right? Okay, so let's take a few minutes and find the slopes here, right? So I'll do that first one. The minute I see a problem like this, I immediately go in and label x1, y1, x2, y2, right? And we're going to do this without a calculator, because remember your quiz is going to be no calculator altogether. So we're going to have y2, which is 2, minus 8, over 4 minus negative 3, negative 6 over 7. All right? Okay, so I'll give you 30 seconds to do the other 3. All right? Let's go. So take a look at this one. Negative 5 plus 5 over 6 minus 3. So that's 0 over 3. It's just 0. So think about it. If you have 0 pieces of chocolate and you want to divide it among 3 people, how much does each get? 0, right? So M is 0.
It's not undefined. It's undefined
when the denominator is 0. So in this case, M is negative 6 minus 1, 8 minus 8, negative 7 over 0. So now think about this. You have 7 pieces of chocolate and you want to distribute it among your 0 friends. That doesn't make sense, right? So that is undefined. Okay, and what about this one?
Undefined.
1 minus 4 over negative 3 minus negative 3. Undefined. Okay, so now here's what we're going to do. So look at this. We had 4 examples. For one, we got a negative, we got a 0, we got an undefined. let's just quickly plot some of these. So in the first case, I have a -3 and 8. And then I have a 4 and a 2. Right? So look at how that line looks. In the second case, I have 3 and -5. And 6 and -5. Right? So take a look at how that line looks. Right? That's a flat horizontal line. How much of a change is there?
None.
There is no change whatsoever. Right? At 8 o'clock, the weather was 67 degrees. At 10 o'clock, the weather is still 67 degrees. There is no change. There is zero slope. Right, because there's no change. There's no change as time goes by. Well, take a look at this one. You have 8 and -6, and then 8 and 1. So take a look at how that looks. That's a vertical line, right? And look at that. Time hasn't even passed, and look at how much like change, quote unquote, there would be, right? So look at that. You can't even calculate how much change that is. So that is undefined. That doesn't make sense. How time doesn't go by, but then there is like all this fluctuation. That doesn't make sense. So think of it that way. All right. What about this one? How would we find slope here? We still have 2 points, right? So we use, I'm going to be a rebel. I'm going to choose this one as x1, y1, not the top one, and x2, y2 here. Does it matter? No. Does not matter. So m is -2 minus 2 over -3 plus 1, -4 over -2, 2. Slope must always be simplified. What if they don't give you the coordinates? You have a graph, but you're not given the coordinates. You pick 2 points. Any 2 points will do. So here, m is 0 minus -1, -4 minus 0, 1 over -4. Okay? All right, so take a look here. In the one hand, we got a positive slope and a negative slope. And why does that matter? How does that matter?
Because when it's a positive slope, it goes that way, and when it's a negative slope, it goes that way.
Right. We always look at graphs from left to right. And you see that for a positive slope, there is positive change. It means your quantities are increasing. So from left to right, the line is, we say, rising. And then for negative slope, there is negative change. Your values are decreasing. The weather is getting colder. The temperature is decreasing. From left to right, it's falling. Yeah.
It's a really good way to check yourself. If you look at a graph and it's going upwards and then your slope is negative, it's a good way to make sure you got it right or not.
And that's exactly what I was going to say next. If you've got a line and it's going up or it's rising, but you calculate a slope and you got a negative number, you already know that you made a mistake. Okay? So lines with positive slope rise to the right. Lines with negative slope do what then? Fall. Well, they fall to the right, like that way. Lines with zero slope are horizontal, no change. M equals 0, yeah. And lines with undefined slope are vertical. Okay? All right. Here we have rate of change. We have a data set, and we want to find the rate of change. What's another word for rate of change? Slope. Good. Okay. Now, before I start a problem like this, I quickly check 2, 4, 6, 8, 10. Those are increasing in even increments. And check that these are increasing in equal increments. 12, 24, 36, 48, 60. They're going up by 12s. Okay, so these are going up in equal increments, and these are going up in equal increments. When that happens, that means you could choose any 2 points for slope. Choose any 2 for slope. Choose any 2 points. All right, so let's choose the first, the second, and the last. I could just totally random. So I'm gonna choose 4, 24, 10, 60. Okay, and now I could do the same. 60 minus 24, 10 minus 4. How much do we get on top? 60 minus 20 is 40. I subtract another 4. So how much? How much? 36 over 6, and that'll be 6. Okay? Yes, you guys are like 2 steps ahead of me all the time. Okay, so the next thing I was going to ask is, would it have been the same value if I chose 2 different points? Yes. Okay. So now let's talk about units. Okay? Here, these values were from here, and those were measured in minutes. These values I got from the second row, and those values were measured in feet. So the rate of change is 6 feet per minute. Okay? All right. Here, how are we going to find rate of change? When you have an equation, we're going to put the equation in y equals mx plus b form, and then the number in front of the x is our slope. So we divide by 6. Y equals 8 over 6, which is 4 over 3, x minus 20 over 3. And this value is always m. All right, so go ahead and do the next one. I'll pause this for a minute. After we multiply everything by 8, the denominators will disappear, right? So, of course, we need to simplify, and we have 4x plus 3y equals 96. And after that, back to algebra 1, we're going to rearrange the equation and solve for y. Make sure, so things to watch out for are, make sure your negatives are properly placed. And don't forget to divide by 3 in the last step. And then the slope in this case is negative 4 over 3. All right? Questions? Thank you, Leah. Any questions? Okay. So now, how about if we need to go backwards? Take a look at the next example. And what we're doing in the next example is we need to find the value of r so that the line that passes through each pair of points has the given slope. Okay? So we're given slope, we need to find one of the coordinates. Okay, if we're working with slope, I start with the formula for slope, right? That's y2 minus y1 over x2 minus x1. And same thing, I plug in everything that I have. M is 4 over 3, is y2, minus y1 is r this time, over 10 minus 4. Okay, 4 minus 10. We got to keep it consistent for the sign. Okay, so now 4 over 3 is negative 3 minus r over negative 6. Now what? Yeah. Okay, so you could do it both ways. You can either multiply both sides by negative 6, or you could cross multiply. Both work equally well. Let's multiply both sides by negative 6. So these will go away.
Can you simplify negative 3 and negative 6?
Right, so negative 6 and 3, that'll be negative 2 times 4, that's negative 8, equals negative 3 minus r.
Then add 3.
Right, then add 3, so negative 5 equals negative r. R is 5. Okay? All right, next one. Negative 4 is our slope, and it equals y2 minus y1 over x2 minus x1. So this is negative 6 plus 2, negative 4 over r minus 8. Okay, so now this is an interesting problem. Let's cross multiply here. Okay? Because there are two different ways of doing this, and I'm going to show you guys both ways. Let's first cross multiply. So here we get negative 4 r minus 8 equal to negative 4. Negative 4r plus 32 equals negative 4. Negative 4r equals what? When I take 32 over to the other side, how much? Negative 36. So then how much is r? 9. Okay. Check out what else I could have done. And this is a fantastic trick to fractions. Does anybody have a, yeah. So you can multiply both sides by r minus 8.
No, by negative 4 by 1 4.
You could just r minus 8.
Okay, that's what I was going for. So take a look. Negative 4 over 1 equals negative 4 over r minus 8. At any given time, when you've got a fraction equals another fraction, if, this is a negative 4 here, if, let's say, the numerators are identical, then all you need to do is set the denominators equal to each other.
Oh,
So you could do 1 equals r minus 8 and r equals 9.
but that's only if the numerator.
That's only if either the two numerators are the same or the two denominators are the same. So you could also have, for example, an equation that looks like this. R minus 2 over 3 is equal to 7 over 3. And now look, now the denominators are completely identical. So all you need to do is set the numerators equal to each other. And how much is r? 9 again. They're not always going to be 9. Okay? Right? So that's just like a cute little trick. It saves you so much time. There's less steps, so less chance for making a careless error and all that stuff. Okay? Yes? Yes? Okay. Let me pause here for a second.